Artificial intelligence applications such as recommendation system, web search, language translation, driverless cars have changed our lives, right? One of the hottest subfields of AI is deep learning. Deep learning is an extension of artificial neural networks. While artificial neural network consists of one hidden layer, deep neural network consists of multiple hidden layers. Many metric operations are used in deep learning analysis. You need to use a library to implement these operations. The most used libraries for deep learning are PyTorch and TensorFlow. TensorFlow is mostly used in industry, while PyTorch is used more for academic research. In this video, I will talk about PyTorch for deep learning. In summary, first of all, I will cover what PyTorch is. I will talk about the advantage for PyTorch. Next, I will show you how to install PyTorch. Finally, I will explain how to use a pre-trained model in PyTorch. I will get a picture from the internet and predict the class of this picture using PyTorch. This is a perfect example for the beginner who wants to learn PyTorch. In this example, I will use a dog picture and predict the dog genus. You can use a different picture such as tea or flowers. Before getting started, we create the videos about AI, machine learning and deep learning. Please don't forget to subscribe and hit the notification bell. Let's go ahead, dive into what PyTorch is. PyTorch is a popular library written in the Python language. It used specifically for deep learning. PyTorch was primarily developed by Facebook. It later became a free and open source library in 2017. With PyTorch, you can easily perform array operations and build dynamic neural networks. You can also speed up this process using the GPU. In other words, you can make fast deep learning projects with the simple and flexible with PyTorch. So, why should we choose PyTorch? Let's take a look at the advantage of PyTorch. PyTorch is very popular because it's easy to use. It has a large community of developers and users. Many companies and research groups use PyTorch for deep learning. Knowing PyTorch is a sought after skill in both industry and academia. You can also make end-to-end projects with PyTorch. With PyTorch, you can use for deep learning project steps such as data processing, model building, and model deployment. As you know, PyTorch is an interpretive language. In PyTorch, it works in eager mode since it's written in Python. You can immediately see the result of the codes you wrote in PyTorch. Thus, you can easily find your debug codes. Cloud is important for big data, right? Cloud services like AWS or Azure make your data analysis easier. You can use PyTorch on the cloud platforms. If you don't have a powerful computer, don't worry. You can use PyTorch for free on both Google Colab and Kaggle kernels. PyTorch also supports parallel computing. So you can use GPU or TPU for mathematical operation in PyTorch. Thus, you can do your deep learning process faster. PyTorch has a large ecosystem. For example, FastAI, which makes it easy to write code for deep learning projects, is written based on PyTorch. With FastAI, you can analyze both computer vision and natural language processing. As you can see, PyTorch is a perfect library for deep learning projects. There are many more reasons to choose PyTorch. I have only mentioned some important advantages here. Let's move on and take a look at how to install PyTorch. If you have a powerful computer, you can install PyTorch on your computer. PyTorch's official website has made installation easy by preparing an easy interface. To install PyTorch, go to the official website of PyTorch, choose the suitable options, and then get this command. After that, run this command in the terminal or the virtual environment you create in Anaconda. To install PyTorch on Anaconda, open the Anaconda prompt. First, create a new virtual environment here. Let me set conda create -- name PyTorch. With this command, a new virtual environment called PyTorch is created. I am not gonna create it again because I have created it before. Next, you have to activate this environment. For this, let me set conda activate the name of the virtual environment. In our case, I am gonna set PyTorch. You can understand that the virtual environment is activated by the name of the environment at the beginning of the line. You paste the command you copy from PyTorch site here and press enter. If your computer has NVIDIA graphics cards, don't forget to select the GPU option. With GPU, you can do your deep learning analysis 50 times faster. If you don't have a powerful computer, don't worry. You can also deep learning analysis using cloud platforms like AWS. But using this cloud service is paid. Colab is a cloud-based free service offered by Google. Colab's interface is similar to Jupyter Notebook. You can run your Python code in Colab. You can also use Colab with GPU. Python is installed in Colab, so you don't need to install it separately. Let's see the installed version of PyTorch now. Import torch print torch dot underline underline version underline underline. You can see the version of PyTorch. One advantage of Colab is that its interface is similar to Jupyter Notebook. If you know how to use Jupyter Notebook, you can use Colab easily. By default, Colab doesn't work with GPU. Let's check it out. Print torch dot CUDA dot is available. As you can see, the output is false. To work with GPU, choose Change Runtime from the Runtime menu and select GPU from the Hardware Accelerator section. Now, let's run this command again. Oops, I got an error message. Let's fix this. I need to run command from the first cell. Because of choosing GPU, I need to run command from the first cell. Let me run this cell. And the next cell, OK. And true is written to the screen. After that, my codes are run on GPU. Perfect, guys. If you buy the pro version of Colab, you can use a better GPU and more memory. The free version is sufficient for the analysis I'm gonna do in this video. So far, I've been introduced to PyTorch and show how to install it. I hope everything is alright. You can write your question in the comment box section. The best way to learn is by doing. Let's go ahead and show a simple example to understand PyTorch. Now, let me show how to image classification with PyTorch. In these examples, I'm gonna get a picture from the internet and specify the class of this picture. Image classification was a difficult problem in the 2000s. But after 2010, with the development of new architectures and the improve of GPUs, image classification become easier to do. Let's get a picture of a dog. If you want, you can use a different image for this analysis. Let's use URLlib library to pull an image from the web. First, let's import this library and request import urllib dot request. Okay, now let's take a URL variable and assign the link of the site where I will get the picture to this variable. URL equals, let me paste this link. Okay, I assigned the link to the variable. You can find this link in the description box below. Let's assign the name of the image found in this link to the file name variable. File name equals quotation marks dog.jpg. Let me get a picture from internet. urllib dot request dot url retrieve url comma file name. Now we got a picture. Let's read the picture with the pillow library and then see the picture with matplotlib. First, let's import the libraries. Import matplotlib dot pyplot as plt. I'm gonna set from pin import image. Let's assign the image to the img variable. Img equals image dot open parenthesis dog dot jpg. Let's see the picture with matplotlib. plt dot imshow img. You can see in the picture. This picture is a very good dog, right? We understand that this picture is a dog, but how will the computer understand this picture? I'm gonna talk about this. Our goal is to find the tag for this picture. For this, I'm gonna use the algorithm based on neural networks. Before giving the image to the algorithm, you need to pre-process the image. Make sure the picture is available for the algorithm. Our picture is color format. It has 3 channels, RGB, and the size of it is 1600, 1200. Remember, data pre-processing steps in PyTorch are called transforms. Now, let's make the image suitable for analysis with transforms. Let's first import PyTorch and then transforms. From Torch Vision, import transforms. Let's use the compose to define a series of transforms to preprocess the picture. Preprocess equals transforms dot compose. First, let's resize the image to 256 size with the resize method. To do this, transforms resize 256. Let's apply center clipping to fit the neural network. Transforms dot center crop 224. As you know, neural network work with numerical data. Let's turn this picture into a tensor in picture-p format. Remember, a tensor is the basic data object in PyTorch. You can think of tensor as a NumPy array with extra features. Transforms dot toTensor. As you know, pictures consist of pixel values. Let's scale the pixel values between 0 and 1. With the scaling, we can make both faster and more accurate predictions. Thus, we create transforms dot normalize mean equals 0.485 0.456 0.406 and then standard deviation equals 0.229 0.224 0.225. Thus, we create data preprocessing steps to make the picture suitable for the neural network and assign it to the preprocessed variable. Now, let's apply the steps to the picture we have. img tensor equals preprocess img. img tensor shape. img tensor 224 in size and consists of 3 channels in the forms of RGB. Deep learning algorithms work with millions of data. It doesn't make sense to give all of this data to the model at once. Data is given to neural networks in groups called batches. The batch size for big 32 or 64. You specify these values according to your analysis. We only have a picture, but deep learning models wait for data to be batched. Now, let's add the batch to our data. I am going to use onSequence method to add a dimension to the data. In this method, we need to specify where to add the dimension. I set 0 to add dimension at the beginning. To do this, let me set batch equals img tensor dot onSequence 0. Let's now see the size of the data. Batch dot shape. Thus, our data was one batch, 3 channels, and 224 pixels. Now, the picture is ready to enter the neural network. As you know, training deep learning models is both time consuming and costly. It makes more sense to use the pre-training model. You can find the pre-trained models in the PyTorch repo. For example, it's very easy to upload a model, use the classify images with Torch Vision. Let's use AlexNet, which won the ImageNet competition in 2012 to classify images. First, let's import models from Torch Vision. I'm gonna set from Torch Vision import models. AlexNet works well for classification pictures. There are different models from AlexNet. You can choose the model you want to suitable for your analysis. Deep learning is more of an art than a science. Now, let's install AlexNet. With the pre-trained option, the previously trained coefficients of the model are loaded. Model equals models dot AlexNet pre-trained equals true. Now, let's create a device variable so that the analysis will run on the GPU if it's on the GPU and the CPU if it isn't. Let me set device equals CUDA if torch dot CUDA dot is available as CPU. Since I'm showing a simple example, a GPU is not required for this analysis. You can also run this analysis on the CPU. Now, let's configure the model with model.eval. Model.eval. Let's choose the device on which the model will run. For this, I use the device variable that I just created. Model.toDevice. Let's assign the command to run the model to the variable y. Let me set y equals model batch dot to device. Let's see the dimension of y. Here, 1 represents the batch of data. Since we have only one image, the batch number is 1. Since the number of classes is 1000, the value of 1000 is written on the screen. Now, let's see the class that gets the most value. Y max index equals torch max y1. Let's print this variable to the screen. Print index y max. Our model found the class with the 258 index with the highest value of 16, but we don't know the class of this index. Let's put the class names from PyTorch side now. Let's create a URL variable first. To do this, URL equals https://pytorch.tips/imagenet-labels. Let's create a class label variable. fname equals imagenet class labels dot txt. Now let's put the list from the internet using these variables. URL lib dot request dot URL retrieve URL fname. Let's open this list. With open, let me copy this and paste as f. Let's assign the row in the list to the classes variable. Classes equals line dot strip for line in f dot readlines. Let's see the tag with the 258 index. Print classes 258. As you can see, the breed of the dog is written on the screen. Let me search this breed. As you can see, this is very nice dog. That's it. I've talked about PyTorch for deep learning. In summary, in this video, I first explained what PyTorch is and its advantages. Next, I show you installation. And lastly, I explained how to predict the class of the image using AlexNet model. I hope you enjoy it. Please don't forget to subscribe, hit the notification bell, give me a like. You can find the notebook link I used in this video in the description box below. See you in the next video. Bye for now.